right, so let's get started. Welcome everyone to our mini-symposium on responsible data science and AI. Let's see. All right, so my name is Jing Liu. I'm the Executive Director of the Michigan Institute for Data Science. I want to spend a couple minutes, give you guys a little bit of background about who we are and why we do this. So for those of you who don't know the Michigan Institute for Data Science, or MIDAS, we're a campus-wide organization supporting data science and AI research across many research fields with the goal of maximizing, I would say, the scientific and the societal impact of such research. So we have about 500 affiliate faculty members coming from every single school and college from 3 University of Michigan campuses. And with that, we're the largest data science and AI institute at any U.S. university and also one of the most scientifically diverse. I also want to mention, closely related to the program today, is that we have actually 2 postdoc training programs, the Michigan Data Science Fellows Program and the Eric and Wendy Schmidt AI in Science postdoc program. And these are unique in that these are among the very few postdoc training programs in the US and also around the world focusing on data science and AI. So today's mini-symposium is part of our annual Future Leaders Summit program. This program, every year we invite PhD students and postdocs from around 20 universities, including major research universities, Midwest universities, and also minority-serving institutions to come to Ann Arbor under the theme of responsible data science and AI. And the goals really are to explore cutting-edge research directions under this theme, and also nurture the next generation of data scientists and AI researchers, especially because they will play a major role in the future to ensure the responsible use of data and AI. And also we want to use this to build momentum on campus with U of M researchers and trainees. So why responsible data science and AI? I think a lot of you all have a pretty good idea. This is not just for human research, but it's for really everything you do with data and AI. You'll see very soon that 2 of the speakers this afternoon are actually in conservation biology and astronomy. But still, you need to, for example, if you study conservation biology, if you want to study sustainability, you need to make sure, for example, rare species are included in your data set. If you do physical science, such as astronomy, you still need to make sure your analysis, your data, your analysis are robust and trustworthy, right? So importantly, so the increasing importance of data and AI in every walk of our lives, for example, everybody knows about ChatGPT. These tools are coming to us at such a breakneck speed, right? So, and many of them are not very transparent. And so really this is responsible data and AI. This really is important for everyone. I want to mention 3 upcoming and related events that we organize. Next Monday, there will be a colloquium in Palmer Commons about implementing AI in health. Next Wednesday, there will be a forum, actually, I think, on North Campus at the music school, and the theme is generative AI, music composition, and creativity. And then in mid-May, May 16th, there will be a 1-day symposium on ethical AI, and this is a joint event with rocket companies, and there will be keynote speakers from academia, government, and industry about AI development, application, and regulation. So today's speakers, I just want to mention, so 4 speakers, Dr. H.V. Jagadish, Ali Sakhe from Microsoft, So the speakers are not only prominent scientists, but the external speakers also represent organizations that have been collaborating with us for a long time. And so Tanya Berger-Wolf, the director of the Translational Data Analytics Institute at the Ohio State University, and Andy Connolly from University of Washington, the director of eScience Institute, which is their data science and AI research hub. And at the end, the panel discussion will be led by Josh Pasick, faculty member here at University of Michigan and also associate director of MIDAS. Dr. Jagadish will give more detailed introduction to these speakers later on, but now I want to welcome Dr. Jagadish for his talk. As you can see, he's a well-decorated faculty member, director of MIDAS, and also Edgar F. Cott Distinguished University Professor and Bernard A. Galler Professor of Computer Science and Engineering. I want to mention two things about Dr. Jagadish. One is he's a computer scientist, but he's also the first person who offered data science ethics MOOC in the country. And he has been working with various organizations, academia and others, to promote ethical use of data science and AI. Another thing I want to mention is his own research is the development and usability of very large databases. Also, in recent years, there's a new focus on data equity systems to ensure the inclusion, fairness, I would say equity, and validity of data. So with that, let's welcome Dr. Jagadish to the
Yep, thanks. Okay. So I want to talk about equity today. As a starting point, I'm going to talk about this works. As a starting point, I want to talk about fairness. Okay, so there's a lot of talk about fairness in the context of AI, and so just to establish a baseline, I want to spend a couple of minutes talking about this. So historically, people think of data scientists like us, think of ourselves as being very objective and very neutral and following where the data goes and so on. And there is value to analyzing data and learning from the data, but I think by now is generally widely accepted that data don't speak for themselves, that there are a number of choices that are made in terms of beginning with choosing what data you look at, what kinds of models you choose to build, etc., that can result in that can produce biased results. I'll be saying more about some of these things in a bit. There are other things too that I think you will probably not have difficulty agreeing with me on as a starting point, which is it's important to make sure that your training data is representative of the population on which you're going to run your model. And it's almost always the case that you train on whatever data happens to be available to you, which is never the data that you'll actually be running your model on. So you hope that the two are going to be the same distribution, right? At least the math that you're using for your system assumes that. A corollary of this is that you're assuming that the future is going to be exactly like the past. Okay, because by definition, if you're learning a model, it's on past data, and you're going to deploy it on future data. And if the data that you're dealing with are things that have, if your learning happens in a relatively short time constant over things that are relatively stable, this is a reasonable assumption. So for example, if you're doing, let's say, optical character recognition, this is a very reasonable assumption to make. It's very unlikely that over the period of time that you train the model, people suddenly start writing in an amazingly different way. However, if you're going to learn models for things like employment decisions, where or admissions decisions, where the goodness of what you have done takes years to become evident to you, the assumption has to be that you're in a static society for that to be for your models to work. Okay, and that's almost never true. And so being data-driven can actually become an impediment to societal change in dimensions in which you might be looking to change society. I'm not going to say more about correlations versus causation. I think enough people have said things about that, so I'm just going to keep going. Okay, now I went too far. I think I'm going to have to find... Sorry about this. There. Okay. So before I get to equity, I want to spend just one slide on diversity. So often, the result of some system is to create a selected group of whatever. And often there is a desire for achieving diversity at the end. And this can mathematically be tricky because you're trying to, diversity is a group construct. And if you're applying scoring or labeling to individual items, the math gets interesting because you're trying to achieve a group result based on individual actions. Okay? And I'm not going to say more about this. It's related to fairness. It's not necessary. It's definitely not the same thing. So I want to get to equity. Equity may sound very much like fairness, but it's actually saying that you treat people differently and you intentionally treat them differently to achieve comparable outcomes. Okay? So where fairness says I want to treat everybody the same, equity explicitly says I want to treat people differently, or subjects differently, or items differently, whatever might be the thing that you're applying this to. So here is this cartoon that I think nicely describes this picture. And I must point out that this cartoon is focused on only one dimension of difference, right, which is height. And when I've been talking about things like diversity and equity and so on, you'll say, well, there's no gender equity here. This is ableist. You assume people can climb boxes and look over, you know, et cetera, et cetera. But be that as it may, it illustrates the concept, I think. Okay. So when one looks at equity and says, oh, we're going to do something different like in that cartoon and have unequal allocation of resources, that kind of sounds very socialist, and then there's a thing of, gee, how are you going to give everybody according to their need? Because that's basically what that equity statement was. I want to convince you that there are many places in society where notions of equity are deeply ingrained, okay, and that we don't question. So it's fair to give every student in class the same amount of time on an exam, okay, and nevertheless, at pretty much every educational institution that I know of in the US, there's a process of allowing extra time for some students with some needs for the extra time on the exams. Okay? And this is very much an unequal time thing. Clearly doesn't meet a fairness criterion of everybody gets the same, and is pretty universal. This applies in other places. So for example, standardized tests are a fair way to measure performance or knowledge on a subject. Right? And our university has now stopped asking for GRE scores for grad students, and I think across the US there's a trend towards moving away from standardized tests. Okay? And the reason for that is equity, where there's been enough scholarship that shows that there's a strong correlation between test performance and socioeconomic status, particularly, but also gender and race, in ways that suggest that working with with standardized tests would be unequitable in terms of the outcomes that would be achieved. Okay, and so this is an explicit case where you've decided what you want to measure, okay? And this is a societally important thing that is done. And really, the reason for me to talk about these everyday examples is to say, when you practice data science, you want to think about issues like this when you start framing your problem. Right? So whatever be the problem it is that you're studying, you've got to say, what data am I going to work with? And what characteristics do these data have? And in what ways are they likely to bias the results I get because of the things that I have chosen to focus on? Okay, so now I want to talk about data equity. So fairness, or validity even, in terms of a learning model, requires or assumes, right, that your training data is representative of the population on which you're going to run the model after you've learned. Okay. Now, in practice, the way that a standard learning algorithm learning process is set up is there's an optimization function, right, which says you minimize total aggregate error. And if you're going to minimize total aggregate error, it is often best to meet that criterion by completely ignoring very small minorities. Okay? So a 10% minority is probably large enough that it won't get ignored. Okay? But again, depends on exactly what you're doing. But there are many cases where you have small minorities, okay, low enough in population occurrence that the way for the model to optimize the stated objective function is to completely ignore that minority and optimize itself for the rest. Okay? Now you fix this either by changing the objective function and having a more complex learning process, okay, or by, in the data, creating additional data points or overweighting, supersampling from the small minorities. Okay, so basically my point is it isn't enough to worry about do I have adequate or fair representation. Equity might require over-representation. Okay, so I want to talk about 4 facets of data equity. Okay, and I'll say what each of these means as we go through. And so I'm going to begin with representation equity, which is pretty much what we were just talking about on the previous slide. Okay? Often, particularly in social data, underrepresented groups, groups that have been historically suppressed are suppressed in the data record, and they tend to be underrepresented. Okay, and in just to give sort of a running example, I'm going to talk about data collection in the and data analysis in the context of COVID. And there were significant racial disparities, especially early in the pandemic, on the availability of testing as well as in the desire of individuals to be tested. Okay? Both of which tended to suppress data collection for African American communities in the US, which led to systematic biases in the collected data. Okay, which then would lead to, if you did a data-based thing, analysis of something and made policy decisions, it would lead to mistaken policy conclusions, potentially. So representation equity, if you think about a table, is about rows and whether you have the right representation in the rows. Feature equity is about the columns in your relational table. You've got to think about what features are you considering in your data set. Okay? If in the process of delivering medical care, for instance, you decide that things like race and income are immaterial. After all, you're treating somebody's illness, and what should it matter? And later, you want to have perform some kind of analysis on racial disparities or income disparities with respect to how, in this case, the pandemic or any other medical issue, health issue was being represented. You have a hard time. You're going to have to impute the missing columns. Okay? And so the question is, if you know that this kind of analysis is likely to be performed or likely to be of value, then the, quote, right way to do this is to collect the data at the time rather than attempt to impute afterwards. Okay, access equity is who has access to the data or the results of the analysis after, right? And in the case of data of all types, even public organizations, government organizations, NGOs tend to want to hoard their data. It's a source of power. And even in the presence of a huge emergency like the COVID pandemic, there were significant barriers to data sharing. Partly because people still have their instincts of hoarding data, and partly because the systems just weren't set up to share. So when there is a view to not sharing, there are barriers that then have to be overcome, and those may be technical. This kind of thing, by the way, is a big issue right now. Everybody's talking about large language models and the impact that they're likely to have on society. And OpenAI, when it started, called itself OpenAI and said that they were going to be open. But as soon as they've had recent successes, it's all the standard things kicking in of we are a for-profit company and we are not open, and we have a proprietary advantage in terms of the language models that we have, right? And if this is something that we as a society are going to use, we've got to think about who has access and what do we know of what's inside a black box. The next thing I want to talk about is outcome equity. There frequently are unintended consequences. And we have to think about how we monitor and mitigate these unintended consequences. In the context of COVID, the best example I could come up with had to do with contact tracing apps and what happened there with especially early in the pandemic. But to me, the place where this is a real issue today societally has to do with all of the web scraping and web-based profile creation that lots of companies do. So one place where there is very good, well-established data collection about what we do in a way that affects our lives is our credit reports. These have been around for decades. Okay? There are well-established processes for each of us to contest what is in our credit reports. Well-established processes for us to go and see what's in there, to be able to contest in the first place. Okay? And in spite of all of that, it's been noted that approximately 20% of the US population has a significantly credit-affecting error in their credit report, in their credit history. And significantly is defined by something like, I think, 75 points on your credit score. Okay? And that is in a well-established process. That's the error rate. With respect to things that people are constructing based on best efforts attempts of whatever was scraped from the web, the error rates are going to be much, much higher. And if these are being used to make employment decisions, financial decisions, even dating decisions, right? It's really problematic because there's no recourse. So want to point out one more little vignette. There's a if you're trying to build a model to predict how sick you are, how sick some patient is, and how much care they need. Okay, how much care they have already consumed is a very good predictor. Okay, and it turned out that in terms of classifying patients and triaging patients in a hospital and sort of figuring out who needs additional care, a standard model that was being used this amongst the many criteria that went in. This was one of the heavily weighted things. Okay, a very influential paper a few years ago noted that a consequence of this, well, they didn't actually find the reason. What they noted was that algorithmically driven care allocation in hospitals was discriminating against African Americans. Okay? And the reason, it turned out, was because the model was constructed to predict greater need for care for people who had already consumed more. And so if somebody came from either because of their availability or resource consumption or fear or dislike, for whatever reason, if they had consumed less medical care in the past, they were assumed to be less sick by the model. Okay, and this is the kind of thing where you really have to think about, this is the GRE exam story. So one thing that is standard for some of you who work with fairness in AI is to say, well, I've got my machine learning problem stated as an optimization problem. And now I realize that, as originally stated, this problem doesn't give me fairness or equity or whatever it is that I want, the goodness properties that I'm looking for. So what I'm going to do is throw in some additional constraints into my optimization problem. Okay? And so with these additional constraints, these fairness or equity constraints that I throw in, I'm now going to solve the optimization problem. And what this explicitly says then is to say, I'm going to give up on the goodness of my algorithm, right? Because I've added more constraints. So by definition, your optimization function is more constrained, is more limited, won't achieve as well as if you didn't have those constraints in place, right? And this, I think, is a very poor way of modeling things, because you set the problem up to have this artificial score in opposition to the fairness or equity thing that you're imposing as a constraint. Okay? The question to address is, did I model things correctly in the first place? Am I scoring the right thing? Right? And usually, if you correct those things, you will have a much better holistic solution to what you're doing, rather than this mathematical dance. okay, which I think is not the right way to address this. I think I can keep going. Trying to think how far we should go. Let me maybe just say a couple more things and then stop. I've said a lot of things about how to do data science right with respect to equity. I want to point out that all of that shouldn't be taken to mean that data science is bad or that algorithmic-driven decisions are bad, right? We've also got to think about what's the alternative. And our baseline is human decision-making. Okay? And in terms of our baseline, we have to recognize that we are all biased. Okay? As hard as we might try, we have deeply ingrained implicit biases. We all have triggers of various types that we react emotionally to and that we don't even know we are doing that. And if you're clever enough, and most of us are more than clever enough, we'll come up with fantastic post hoc explanations for decisions that were made intuitively and in a completely biased way. Right? And so what happens with human decision-making is there are lots of biases, and these are hard to measure and very hard to prove. With algorithms, at least to the extent that you can apply mathematical definitions for whatever it is that you're trying to accomplish, you can measure something, you can run it against a million instances and check things out. And there is some scope of doing things that could, in some ways, be better. Okay? This isn't going to happen by itself, and it's certainly not going to happen without care. And if we do bad data science, we can create algorithms that do very poorly. Right? But I actually am optimistic that algorithmic decision-making can make us as humans less biased, okay? Which is not just that they're equal or that they're good enough, but that they can actually be better. Right. What time should I finish? Okay. So this is the hype, right? And companies propagate this too. And in practice, I think this is more like what things look like. There are many, many steps in the data ecosystem that you have to deal with before you get to doing the model building. And you build your model, and then you've got to interpret the results that you get from there. And if you're going to worry about things like fairness and equity, you have to, it isn't enough just to look at the model. If you're dealing with bad data, you're going to get bad answers. And so what I want to encourage you to do is to think about all of the steps in this pipeline and think about how things could go wrong. I have a lot of things that I can say about each of these. And in the interest of time, I'm going to flash these through. So data cleaning, for instance, is a thing that most people with experience in doing this will say is the place that they spend the most time. Okay? An important thing in cleaning data is you there's an assumption that you know what clean data looks like. Okay, which means you're filling in things, you're correcting things. And if you don't know what good data is supposed to look like or clean data is supposed to look like, then you can't clean data. Right? And people make very strong assumptions. So for example, missing values are almost never missing at random. Okay? There's a reason why things are missing. And that reason might be, for instance, that somebody was, some kind of data was difficult to collect, or some people didn't want to reveal some things about themselves, right? And assuming that those things are distributed like everything else, which is a very standard data cleaning assumption, gives you a data set that looks clean, but has a lot of garbage in it now. Yeah, let me go through this example, actually. This is probably worth doing. So you have a customer database that you're collecting, one record per customer. You defined a gender field. And when you look at what you got, you found that your customers, 48% had filled in M, 32% were filled in F, 20% had left it blank. What are you going to assume about the 20%? So simple solutions that people do is, one is ignore these records. They're not complete. Okay? And if this 20% represents a fraction of the population that has characteristics or needs that are different from the 80% who had filled this in, then that is an inappropriate thing to do. So that's actually a pretty bad thing to do. Okay, another thing you can do is to impute the missing values. And then the question is, how do you impute it? Okay, and I'm just going to keep going. Representation choices matter. There's often a lot of pre-processing to represent things. So for instance, you might bucketize values or define geographic boundaries or describe sentiments to text. And often you don't question how you did that. And you can get very different answers depending on how you do that. Right? You've all heard of gerrymandering as an example, right, in the political context. But the same thing applies to any data analysis. And even if you're not doing it intentionally, you might just do it thoughtlessly. Okay, I think I'm going to let me just go to the end. So I just want to point out, Jing mentioned this MOOC, so just wanted to give you the link. You can Google it, Google Data Science Ethics. And with that, I think I'm going to stop and allow a couple of minutes for questions.
Bring you the mic.
So when you talk about fairness in terms of access to data, it feels like that's only one step. I mean, one of the challenges we're facing with a lot of the kind of data-driven projects is that it's great to make data accessible to everybody, but it doesn't solve the fact that there are certain institutes and organizations and groups who have many more resources in order to be successful associated with it. And I was wondering, do you have thoughts on how do you go beyond the access? What can we actually do to try and address, particularly in a world of big data, what can we do to try and make that more equitable?
Yeah. So a thing that I'm going to answer it in the context of this slide. So there's a subfield of data management called provenance. And the idea is that you associate provenance with every data item. And the theory for actually even the algorithms for how to do this is all pretty well known. Okay? There's a certain overhead to doing this. And at the end of the day, if I give you the results of some analysis, you can ask me for the provenance of it, and if I have an appropriately configured system, I can give you the full provenance. I can see exactly what data I used, how I used it, what I did with it, the whole caboodle. Okay. So the methodology for doing that is known, but there are two major problems associated with actually using this in practice. First, there are proprietary concerns. Okay? If there's any profit making involved anywhere, it's unlikely that there'd be a willingness to share at that level. And it's unreasonable to expect that. Okay? There are also potentially privacy concerns for if there are individuals whose data was involved with this. So even if there weren't proprietary concerns, there would be that. But then there is the other thing, which is if, as a user, you ask, well, can you give me an explanation for this result? And I say, well, here is this 50 gigabytes of stuff, right? And you figured out this gobbledygook. That's completely useless. So what one needs to do is to be able to have an appropriate level of explanation to be able to develop that kind of transparency. And that is still, I think, at its infancy as an academic question. There isn't enough of an understanding of what constitutes good explanations. There is a robust and growing field trying to do this better. And I think that's the nature of where I think we're going to have to land, where there will be proprietary stuff, there will be things that is privacy limited, and we still get adequate understanding and adequate trust. Any other questions? Yeah.
So we often assume that algorithmic approach is the way to go. How do we? And occasionally, the algorithmic approach in and of itself, the technocratic approach, is the one that introduces bias, particularly when it is, designed in absence of the community participation, the stakeholder participation, the engagement of those for whom the solution is intended as part of the solution designers. Can you comment on the do no harm in the decision to use an algorithmic and data-driven approach in the first place, and this sort of gauging the value added versus harm done in applying these kinds of solutions?
Yeah, and I think that the reasons why the adoption of algorithmic methods can do harm is either because of a representational harm, because the right kind of data is not included, or because of an access harm, because it assumes, for instance, that people have access to a cell phone and people who don't have cell phones can't do it. Things like this. And so my belief is that if one is going through systematically and addressing the equity issues of the type that I talked about, and I am not going to claim that that is complete, but it is as complete as I know today. And addressing it adequately will usually require understanding the subjects involved, right? And so community participation, for instance, is a time-honored way to develop that understanding. Then hopefully we will avoid the kind of misfires that you're talking about. In other words, I don't believe that it is the use of the algorithm in itself that's the problem. It is the use of the algorithm in the absence of having addressed an issue, or more than one issue, that's causing it to be twisted in some way. So, and you don't agree, and we can argue about it over a beer.